Hi, welcome to Boaz International School. We are here at Lavington. We offer homeschooling, tuition, and mentorship programs. With you today is teacher Philip. I'll be introducing you to something called the structure of an atom. This is a topic in IGCSE Year 10 Cambridge syllabus. I hope you will enjoy the lesson. Now, many people have been talking about atom. But the question is, do they understand what it entails? Today, I just want to talk about the structure of an atom. And when we talk about the structure of an atom, the first thing that you need to know is, can you define what is an atom? The second thing is, what are the subatomic particles in the structure of an atom? Then we also talk about what are the characteristics of these subatomic particles. After that, we will look at the parts of an atom, the structure, how it is drawn, and label the parts, and also talk about where electrons, protons, and neutrons are located. Then after that, we will talk about the electron arrangement or electron configuration. And lastly, we will conclude by talking about atomic number and mass number. And before I start doing anything again, I would like to remind you that making chemistry easy or difficult is about your attitude. So just have a positive attitude and everything will be okay. So let me start. What is an atom? We define an atom as is defined as the smallest particle of an element which can take part in a chemical reaction. An atom is the smallest particle of an element which can take part in a chemical reaction. Something comes in here. What is an element then? You need to ask yourself, what is an element? An element is defined as the pure substance that cannot be split by chemical means. Any substance that cannot be split by chemical means is referred to as an element. Now, after knowing all this, we need to talk about subatomic particles. As we have said, atom is subdivided into 3 subatomic particles. One is called proton, the second one is called neutrons, and lastly we have what we call electrons. When we talk about protons, we say something about their characteristics. Protons are positively charged. Neutrons have 0 charge. And electrons are negatively charged. Protons positively charged, neutrons 0 charge, and electrons negatively charged. Now, the number of protons and the number of electrons are always equal. This means that they contribute to what we call let me rub this and explain it further. Now, in an exam, you might be asked to explain why atoms are electrically neutral. When talking about atoms being electrically neutral, we are simply talking about protons and electrons. When the number of protons is equal to the number of electrons, we say that that atom is electrically neutral. The second thing is, you can be asked in an exam, which particle contributes to the stability of an atom. This one here, we talk about what we call the neutrons. They are the ones that contribute to stability of an atom. If you take chemistry to a higher level, you will be talking about something called radioactivity. This is where you will understand how neutrons are used under radioactivity and in making of any radioactive isotopes. Now, after knowing all this, I want us to look at the structure of an atom itself. The structure of an atom I will be drawing. Now, if you look at what I have here, I have two circles, the smaller one and the bigger one, and the inner circle is shaded. The shaded region here is called the nucleus, and the unshaded part is called the energy level. Energy level or electron shell. Now, if you look at the second diagram here, I'll name them A and B. We have the particles, the subatomic particles, distributed within the structure of an atom. From this diagram here, you can note that electrons are contained in the energy levels, whereas protons and neutrons are located in the nucleus. The proton plus neutron added together, they form what we call the nucleons. That is proton plus neutron. After knowing all this is just to know the structure, how it looks and the parts. Now we want to define what is nucleus and what is an energy level or electron shell. Nucleus is the centermost part of an atom, where protons and neutrons are located. Then when we talk about energy level or electron shell, is the region that surrounds the nucleus, where electrons are located. Very important. When defining nucleus, we want to see the location, centermost part of an atom. And to be a good student, also tell us something that we have protons and neutrons within the nucleus. At the same time, when talking about energy levels or electron shell, we want to see that it is the region that surrounds the nucleus. And don't just stop there. Tell us that this is where electrons are located. I hope that one is clear. So after this, I want to talk about energy level in details. Now, when we talk about energy level in details, what I want to talk about is numbering of energy level. Now, this depends with the number of electrons that are present within the structure of an atom. For example, I'll use sodium. Sodium is written Na, atomic number 11. That means it has got 11 electrons. I will have another one called beryllium. Beryllium is atomic number 4, having 4 electrons. And hydrogen, atomic number 1, 1 electron. How can we distribute them? How can we number these energy levels? I will draw it. Now, this one here, the one that is shaded, is the nucleus. Whereas the unshaded parts these are the energy levels. How do we number them? Very important. When numbering energy levels, we start with the one that is closest to the nucleus. So if you look at these energy levels that I have here, the one that is closest is the first one, it is here, followed by this one, and lastly we have that number 3. So if any case you are supposed to distribute these electrons within the structure of an atom, we start from the first energy level, we move to the second energy level, and lastly the third energy level. Having known how we do this, I want us to try and distribute what we have here, the hydrogen atom, beryllium atom, and sodium atom. How do we distribute these electrons? Now, before we talk about distribution of these sodium, beryllium, and hydrogen, we want to talk about the rules of distributing electrons. The rules. Generally, we have two rules. Number one states that the first energy level can only accommodate a maximum of 2 electrons. What does that mean? For example, hydrogen has got 1 electron, so it means it will only occupy the first energy level. Whereas beryllium has got 4 electrons, the first energy level will accommodate 2 maximum, which means 2 must remain, and the ones that remain will be taken or carried to the next energy level. Let's see, what is the second rule saying? For the first 20 elements of the periodic table, the second and third energy level can only accommodate a maximum of 8 electrons. Very important. For the case of the first 20 elements, the second and the third energy level can accommodate a maximum of 8 electrons. What is important here? We are talking about maximum number, and we are talking about specific energy level. For the first, maximum is 2. For the first 20 elements of the periodic table, the second and third energy level can accommodate a maximum of 8 electrons. Very important. You must have this one at your fingertips as a student, because this one will apply everywhere. Now, can we distribute them? Yes. Let's try. I will start with hydrogen. I'll indicate hydrogen. And because the number is just 1, the number of electrons, it means we only have 1 energy level. So I'll come here and represent my electron. Electrons can be indicated using a cross or a dot. So this is the first one within the energy level. And somebody will also draw it this way here. I'll use a different pen. Then you have your electron there. The question is, which one is correct? Both are correct. Both are correct. Now after that, let me draw the one for beryllium. Now because beryllium has got 4 electrons, I will have the first 2 using dots now, and the remaining 2 will occupy the next energy level, which will be here, which can also be represented as beryllium with the 2 energy levels. Then I'll have my electrons here. After that, let's try sodium. Now, sodium has got 11 electrons. It means the first energy level will have 2 electrons. Now because we have 11, we take away 2, we remain with 9. So I'll bring the next energy level. Now out of 9, the second energy level can accumulate a maximum of 8 electrons. I'll draw the 8 here. And lastly, have the last energy level. With 1 electron. Now the question is, why am I having 2 electrons each paired and not just distributing them randomly? Why pairing of electrons and not randomly distributed? Well, this one here I will explain in my next class, hopefully tomorrow. So I hope you will tune in and listen to what is happening here. So after knowing how to distribute our electrons, we want to see how do we generate electronic arrangement or electronic configuration from what we have here. When we are talking about electronic configuration or electronic arrangement, it is simply the distribution of electrons within the structure of an atom. The question is, where do we start from? Now, having the structure of an atom here, I will start with this one for sodium. I will check the innermost energy level has got 2 electrons. Then move to the next energy level has got 8. Then move to the next, which is the last energy level, which is 1. The 3 can be separated by comma or full stop. So this first value 2 is from the first energy level, 8 from the second energy level, and 1 from the last energy level. Coming to beryllium, I'll have the first energy level having 2, comma, and the second having 2. For the case of hydrogen, it is just 1. My question is, from what I have here, what information can you obtain from electronic arrangement? From electronic arrangement, let me just write it here. How does electronic arrangement or configuration helps a scientist? Importance of electronic arrangement. Now, from the electronic arrangement, one, we can be able to know the number of energy levels. Energy levels occupied. 2, we can also talk about period and group. This one here, we will talk about it under periodic table as our next lesson. Then we can also know whether it is a metal or non-metal. So that is basically all I had for today. And in summary, we've just talked about the structure of an atom. And when we talk about the structure of an atom, you need to know how to define an atom by saying that atoms is just the smallest particle of an element which can take part in a chemical reaction. Then you ask yourself, what is then an element? An element is simply a pure substance that cannot be split by chemical means. Then after knowing all that, talk about the three subatomic particles. One is proton, we have neutrons, and we have electrons. Talk about their characteristics in terms of the charges. Protons, positively charged, electrons, negatively charged, neutrons, zero charge. Then after that, talk about the structure of an atom. Can you be able to draw a well-labeled structure where you have the nucleus and the energy level, or the electron shell? Tell us, what is it that is contained in the nucleus? In the nucleus, I've said we have nucleons, that is protons and neutrons. Then within the energy level or electron shell, we have electrons. Then there is a question that I asked, or I said also, that protons and electrons are always equal in number. This contributes to electrical stability or electrically neutral. We say that atoms are electrically neutral because they have the same number of protons and the same number of electrons. Then I've also said that in the nucleus we have neutrons. These just contribute to the stability of an element by referring you to what is called radioactivity. You can consider the thorium and the rest. Now that brings us to the end of this lesson. I hope you've enjoyed. Until next time, bye bye.